We have seen the guidelines for strong password in domain 1 and 2, but then for web application specific, let's discuss that once. The minimum length of 12 to 14 characters if permitted. Generating passwords randomly wherever feasible. Avoid password based on repetition, dictionary words, letters or number sequences. Usernames, relatives names, pet names, romantic links, current or past, biographical information, example ID numbers, ancestors' name or dates, including numbers and symbols in passwords if allowed by the system. If the system recognizes the case as significant, using capital and lowercase letters. Avoiding using the same password for multiple sites or purposes. Avoid using something that the public or workmates know you strongly like or dislike. Now, when you look at that, it's very good to say on paper or tell in a presentation that use minimum 12 to 14 characters if permitted. But in reality, many of the people don't use 12 characters. Now there is a method also for making passwords. Easy to remember password even if it is long. Now Mary had a little lamb. So MHALL is Mary had a little lamb. So you give different combinations of that. Instead of 1L you can put 7. Then add some special characters at the end or add some numbers also in the end. So you can make something that is easy to remember, at the same time it is long. Then random password is in your banking transactions. Before you do a financial transaction, let's say you are buying something from online site, random password is maybe a OTP is generated and put. Then repetition, you have to avoid passwords based on repetition, like AAA 2345, like that, dictionary words, letter or number sequences, ABCD, 1, 2, 3, 4, usernames, relatives. So there are several criteria for setting up strong password. You should make sure that it fulfills the criteria so that your account is safe. Brute force will be very difficult if you have a long password, and follow the rules of having the alphanumeric special character validation. And don't use the same password, one for Google, the same thing is repeated for Yahoo, MSN, the Flipkart site, Snapdeal site. So keep different passwords if possible. And suppose, let's say that I like chocolate ice cream. So I make combinations out of chocolate and make it as a password. So avoid using something that the public or workmates know that you strongly like or dislike. So that's exactly the example for that. The automated tests of password strength are problematic. Any network-based checking necessarily involves submitting one's password to a purpose declared system somewhere. The relevant network traffic is easily identifiable as the password saving requires much effort for the attacker. Passwords which are vulnerable to social engineering and guessing attacks cannot be properly checked automatically. Let's test some passwords. 1, 2, 3, 4, 5 instantly crackable using the tools ABCDEFG. Then ABCDEFG 1, 2, 3, 4, 5. PC would take around 37 years to crack. Example, so it's there. You need some creative trial and error, some research to be done, some social engineering techniques. In the end, you will find that all the characters or all the passwords that are mentioned above are easily crackable. So, based on the length of the password, the system computes that it takes 1351 years to crack. But then ABCD 1, 2, 3, 4 is pretty simple to crack if you have the right tools, right methods, right methodology. We all heard of two-factor authentication. So two-factor authentication is a method where in addition to your password, you use some other form of authentication. So it cannot be two passwords, then it becomes a multi-level authentication. So one should be a remembered info and the other should be a possessed info. Now there are different methods there. Of late it's been on your laptops you would have seen facial recognition via webcam for unlocking the computer. Then on the mobile phones, protect your account via RSA token, or there are several apps available for the Android and iOS markets. Then your dedicated confirmation of suspicious payments via the text messages. So there are multiple levels of doing that. In the banking industry specifically, the banks for the corporate customers give a token, something similar to a RSA or a Vasco. So some kind of token is given. It was, I remember first it came in early 2000s in HSBC. So a lot of multi-layered authentication methodologies or different methods are being used by the banks itself. If you need to transfer money to a third party, you need your account login details, you need your transaction ID, you need the transaction password, then it gives you an option to enter the third password or a token information. So there are multi levels of authentication which are performed on critical services. Let's look at cross-site scripting, XSS. The attack vector is average, the prevalence is very widespread, the detectability is easy, and the impact is moderate. What is XSS? Attacker sends a malicious code to an innocent user's browser. The malicious code might be might be reflected from the web input, the form or hidden field or URL. It could have been stored in the database, sent directly to the rich JavaScript client. So virtually every web application has this problem. Normally, JavaScript commands are sent from the server to the browser and executed. Now, XSS happens when an attacker tricks a logged in victim into entering the JavaScript into his browser and submitting it to the server. The server then dutifully echoes them to the browser, which the browser thinks that they are commands and executes them. The attacker tricks the browser into buying things, transferring money, delivering cookies, etc. etc. Now, the fix for this is to filter and encode all potentially dangerous characters so that the application does not return data that the browser will interpret as executable. Any unescaped or unencoded data that is returned to the browser is a very serious security risk. Now there are characters like greater than, less than, colon, exclamation, open bracket, square close bracket, semicolon, colon, forward slash. So there are several characters that need to be filtered. What is the typical impact? It is steal a user session, steal sensitive data, rewrite the web page, redirect users to phishing or malware sites, and the most severe is install XSS proxy, which allows attackers to observe and direct all user behavior on vulnerable sites and force users to other sites. Now, if you look at an example, let's take the example of Bob and Alice, which is very widely used in information security teachings. Now, let's say that Bob is hosting a website with a forum allowing users to post comments similar to our NPTEL website. Now Alice posts a comment with JavaScript embedded in it. All users can now see this comment. Alice visits or Mallory visits the site. Bob's site dutifully prints Alice's comments which contain the JavaScript. Mallory's browser, thinking that the JavaScript should be executed, executes it. So that JavaScript is malicious and it causes havoc in the system. There is a variation in XSS called reflected XSS. So reflected XSS are those where the injected script is reflected off the web server, such as in an error message, in a search result, or any other response that may include some or all of the input sent to the server as a part of the request. Reflected attacks are delivered to victims via another route, such as from an email message or from some other site. So when a user is tricked into clicking a malicious link, submitting a typically crafted form, or even just browsing to a malicious site, the injected code travels or traverses to the vulnerable website, which reflects the attack back to the user's browser. The browser then executes the code because it came from a trusted server. Reflected XSS is also sometimes referred to as non-persistent XSS or type 2 XSS. How the attackers do a reflected attack? Let's again take the case of Alice, Bob and Mallory. Alice visits Bob's website which stores sensitive data. Now after Alice logs in, Mallory observes that Bob's website is vulnerable to an XSS attack. Mallory crafts a URL to exploit the vulnerability and sends an email to Alice, enticing her to click a link for the URL under some false pretense. The URL will point to Bob's website but will contain Mallory's malicious code. Alice clicks on Mallory's link while logged into Bob's website itself. Now, the malicious script embedded in the URL executes in Alice's browser as if it came directly from Bob's browser. So that is why this is actually an XSS vulnerability and it is called a type 2 or a reflected XSS. Then there is something called a persistent XSS. The stored attacks are those where the injected script is permanently stored on the target servers, such as a database, in a message forum, in the visitors log, in the comment field, and or any other field. The victim then retrieves the malicious script from the server when it requests the stored information. So stored XSS is also sometimes called as persistent or type 1 XSS. This is much more insiders since the user does not see the attack on the page. So it affects, XSS can affect Ajax also, and we also have to filter untrusted input to CSS also, to HTML attributes, to JavaScript, URL parameters or query strings. This is all in addition to the HTML elements. So you have to filter out the unnecessary characters. So where all it affects? So what you have to note is any scripting language that the browser can process is vulnerable to this kind of attacks. Local XSS, it's a DOM based XSS, or sometimes it is called as type 0 XSS also. So this is an XSS attack where the attack payload is executed as a result of modifying the DOM environment in the victim's browser used by the original client-side script so that the client-side code runs in an unexpected manner. That is, the page itself means the HTTP response that is there does not change, but the client side code contained in the page executes differently due to malicious modifications. This is in contrast to the XSS attacks we have seen so far, which is the stored or reflected, where the attack payload is placed in the response page due to the server side flaw. The attack patterns of XSS is given. Again, like I mentioned earlier, the source is given on the bottom right. You can go to that URL and there is a XSS cheat sheet available there where all these scripts are there. The hackers.org also has a page where they have classified from I6 or 7 onwards to the latest version and which particular attack works on which particular browser. So it's a really good informative site. If you want to try out XSS on your own VM, go to the site, download the cheat sheet and try it out. A few more samples are given. The cheat sheet, I have given the URL there. Bypassing client-side validation. Client-side validation, if it is done, is always insecure. Now, there are a lot of plugins, add-ons available for Mozilla, for Chrome, for Internet Explorer. Tamper Data is a very popular plugin for add-on for Firefox. You can stop all outgoing HTTP requests in your browser and tamper the contained headers, host data and pass parameters after the client-side validation took place, but before they are actually submitted to the server. So, once you enter the username and password, after the client-side validation happens, if it is a client-side validation, you install a plugin like or add-on like Tamper Data, trap that particular request. You will know multiple things from there. One, what is the actual username entered? You can alter it. What is the password entered? If password is not encoded or encrypted, you will come to know the password in plain text. If it is encoded, you can further go and see what kind of encryption is used. So there are many things that can be done. The most popular one is Tamper Data Request Maker. The same thing you can do it in Burp Suite also. You need to install it as a proxy on port 8008 and then use Burp. You can still do the same thing. What is the protection mechanism for XSS or how to eliminate XSS? First thing is, don't include user supplied input in your output. How do you defend against XSS? Output encode all user supplied input. There is OWASP Enterprise Security API, use it. For GWT, for Google, use that. Perform whitelist input validation on user input. We have seen that. Use an HTML sanitizer for larger user supplied HTML chunks. So there is OWASP Java HTML sanitizer. Now for your information, ASP.NET comes with XSS protection enabled by default. You can turn it off also in the web.config file. We will now go to A4, which is insecure direct object reference. The attack vector is easy. The prevalence is common, the detectability is easy, and the impact is moderate. Now, how do you protect access to your data? This is a part of enforcing proper authorization along with A7, that is A7 of OWASP, which is failure to restrict URL access. The common mistakes that are done are only listing the authorized objects for current user, hiding the object references in the hidden fields, and then not enforcing these restrictions on the server side. That's the presentation layer has access control. Attacker simply tampers with the parameter value. What is the typical impact? Users are able to access unauthorized files or data. That is the impact. Now, if I have to give an example, now you are checking online on how you did in an exam. So you have HTTP University slash marks id equal to something, checking how your fellow students did. You are not supposed to see how your fellow students did, so you are giving the id equal to, you are changing and saying, checking the distribution among class, so there also the url is given. Now what actually happens is, eliminate the protection is eliminate the direct object reference. If you see in the previous slide, this is a wrong way of doing it, because if I know your id, I can go and in the url I can put it, and then I can see what marks you have scored or what the other person has scored. So there is a direct objects reference there, vulnerability there. Now eliminate the direct object reference, replace with temporary mapping value. Example is OWASP ESAP access reference map. Validate the direct object reference, verify the parameter value format, verify user authorization to access the target object, then query constraint work, great, data access restriction, verify the requested mode of access is allowed to the target object, read, write, delete. Now this, what you have to note here is, this is not the method that is to be used, id equal to. It should be in a form where a normal attacker or an attacker cannot decipher very simply and do a insecure direct object reference. Then we go to security misconfigurations. Here the attack vector is easy, the prevalence is common, detectability is easy, and impact is moderate. Application misconfiguration attacks exploit the configuration weakness in the web applications. So web applications rely on a secure foundation everywhere, right from the OS up to the app server. So don't forget the libraries also that you are using. Libraries also can be vulnerable. Is your source code a secret? Think of all the places that your source code will go. Security should not require secret source code. Do you change all credentials regularly in your production environment? These are things to ponder. Misconfiguration is defined as a configuration mistake that results in unintended application behavior that includes misuse of default passwords, misuse of privileges, and excessive debugging information disclosure. The effect of misconfiguration can lead to service outages, loss of sensitive data, or any other serious problem that can occur. What is the typical impact? Install a backdoor through missing OS or server patch. Now, XSS flaws exploit due to missing application framework patches, unauthorized access to default accounts, application functionality or data, or unused but accessible functionality due to poor server configuration. Now all these can be severe. You can have a partial or full data loss. There could be data modification. There could be a compromise of the full system, and recovery is going to be very expensive. The protection for this: verify your system's configuration management, secure configuration hardening guideline. So hardening we have discussed under OS domain file. Automation is really useful. If you have a large number of servers and you need to do hardening, then automation is really useful. You must cover the entire platform and application. Keep up with the patches for all components. So just by installing a patch for your Linux server or Windows server does not mean that your system is no longer vulnerable. You may be using some insecure components, or you may be requiring some framework which is older version and patches have been released and you have not updated. So update those patches. So analyze security effect of changes. So before you actually put it in production, test it and see what is the effect on not only the security but also the functionality. Deactivate or disable unnecessary stuff like the ports that you don't require, block it. Services that you don't require, block it. The default accounts that come with it, disable it. And if multiple sites are there, test site has been put and all that, disable it. Then verify the implementation. So you do a scanning to find if it is a generic configuration or if there is a missing patch problem. So if you ask a question, am I at risk? Then you let ask the following question. Is the software out of date? Are any unnecessary features enabled? Are default accounts and associated credentials unchanged? Does error handling reveal traces to users, stack traces to users? Are the security setting not set to secure values? Or are the security settings set to insecure values? Now, is a default installation being used? Is there a consistency maintained between versions or configurations? Then, is the default configuration option restricted? Are all the non-required ports blocked? Are the roles and privileges restricted? And is the configuration centralized? Then, has a scan or audit been done on that particular site? Whether strong encryption has been used? So you can probably add more to this, but more or less, this is what you need to do